Sunita from EPS third year, and today I will explain LVDT experiment. Objective of this experiment is to determine the characteristics of LVDT. So this is setup for LVDT. So LVDT is most widely used inductive transducer which converts linear displacement into electrical signals. So the basic construction of this is the basic construction of LVDT, and this is a cross-sectional view of LVDT. So the transformer consists of a single primary coil which is connected to AC supply and two secondary coils S1 and S2. The secondary windings have equal number of turns and are identically placed on either side of primary coil. A movable soft iron is placed inside the transformer. The displacement to be measured is applied to the arm attached to the soft iron core. Since the primary winding is excited by an AC source, it produces an alternating magnetic field which in turn induces alternating current voltage into secondary coils. The core causes the magnetic field generated by primary winding to be coupled to the secondary. When the core is centered perfectly between the secondary and the primary, as shown here, it is at 0. The voltage induced in each secondary is equal in amplitude and 180 degree out of phase. Thus the LVDT output should be 0 because the voltage cancels each other. But as we can see here, there is some residue voltage because of some external factors. Now displacing the core to the left causes S1 to be more strongly coupled to the primary than S2, and resulting high negative voltage. Here negative denotes core towards left side. Now displacing the core to the right causes S2 to be more strongly coupled to the primary than S2, and resulting positive high voltage. Here positive means core is towards right side. So these are the complete readings which I took when I did the experiment, and when we plot the graph between output voltage and displacement, we see that graph is linear, and after a certain displacement graph is no more linear. So this is called linear range of LVDT, and at zero displacement voltage is not zero, which is called residue voltage. So we can calculate sensitivity by dividing change in voltage by change in displacement, and we can see that sensitivity is quite high, and resolution of LVDT is essentially infinite because it operates on principle of magnetic coupling. So LVDT can also be used to measure pressure. The pressure sensing diaphragm can be attached to this arm. As pressure changes, displacement will changes, and as displacement changes, voltage will changes, and this is how we can measure pressure using LVDT. So thank you for listening. I hope this video will help you.